Hello and good day to all fellow scientists. We are back here again with another video, another fresh lesson of financial maths, grade 10. Hope you all are doing good. Hope you all had a beautiful weekend, beautiful Easter weekend. Yeah, I enjoyed my Easter weekend. It was very nice. So, if you are new to our family, welcome to Sensei's family of scientists. So, please subscribe if you have not yet subscribed to our channel. And if you like what I'm doing, just like and comment and just say, Sensei, I love what you're doing. Keep it up, just to keep the algorithm going. So, on today's lesson, we'll be focusing on different parts of interest, compounded interest, because in most cases, yes, interest may be compounded annually. In some cases, interest may be compounded monthly, weekly, quarterly, semi-annually, or daily. So today we're gonna be dealing with such lessons. And if you have inquiries, you want me to be your personal tutor, my WhatsApp number is 081 537 9527. You can WhatsApp me for any inquiries, and yeah, everything will be sorted. I also have a Patreon account, Patreon channel, where I post past paper questions, tackling past paper questions. It's math and science tutorials. Yeah, you can check it up at Patreon. So now we can start. So first of all, before we start, let's now take a look at this notes here. So remember from the previous lesson, we have discussed the meaning of the symbols like A, which is accumulated amount, which is the invested amount, which is the income after interest. This one is the invested amount, which is the principal amount. This is 1 plus interest over the number of years, or the number of months, which is the time period, whether you're doing it daily, weekly, monthly, quarterly, semi-annually, or annually. And this is the time period again, and the number of years. So now here, for example, let's say they tell us that our interest is compounded monthly. So if our interest is compounded monthly, then which means that here you can see it's I divided by 2. I is the interest rate. It's the interest rate divided by 12. So which means here we will just say, let's say maybe it's 7% compounded annually. We will say 7% over 12, or we can just do the 7% in decimals, which will be 0.07 over 12. Then the n, it says 12 because of its compounded monthly, so which means every month the money will grow monthly every month. So which means that here at n it will be 12, and let's say maybe they say 2 years, it will be 12 times 2, because we know that if it's compounded monthly, the interest will be increasing, the money will be increasing every month. Let's say maybe this month is 2000, next month is 2100, the next month 2200, after that, and so forth and so forth and so forth, for 2 full years. So yeah, so now let's start with a question so that you can understand it better. But this one is just easy. I ensure you after this lesson you will be knowing everything, you will be acing it, trust me. So now, first question says, Mandla puts 5,500 into his savings account, paying 7.5 annual interest compounded quarterly. At this rate, how much money will be in his account after 2 years? So I first start by doing this always. So I must note down everything that I have, the interest, number of years, the accumulated amount, and the principal amount. So what do we have? This accumulated amount? No, we are gonna look for it. 5,500, it's the principal amount or the invested amount which he puts in the account first. The interest is 7.5%, which we can write in decimals. It will be 0.075. If you all may be asking, how did I find this? It's just easy. Since we know that percentage, it means something over 100. It's 7.5 divided by 100, which will be 0.075. So that's how we do it in decimals. And the number of years, they gave us 2 years, and it's quarterly. So let's highlight this, it will come in handy. So now let's start punching in everything using the formula there. So some of y'all may write it as an R, which is for the rate. It's the same thing. You can write it like that. It's just the same thing. They won't penalize you if you don't do it like this. So now here we know that you can, if you have done this before, you can pause the video and try doing everything on your own. Then after that, you will just do everything as corrections to see whether, as a practice exercise, to see whether you really get it or not, so that you can just practice and be perfect with it. So it's 1 plus 0.075 over, it's quarterly, it's divided by 4, because we know that in a year we have 4 quarters, like term 1, 2, 3, and 4. So we have 4 multiplied by 2, which is the number of years. So everything that is here, we just punch it in the calculator. 5501 plus 0.7075 to the power 4 multiplied by 2. So the answer, final answer will be 6381. Since it's finance, we are dealing with money, cash, so we can just write it in 2 decimals. And don't forget the currency. If you make the mistake of not writing the currency, they will penalize you. So remember that. So our final answer is 6,381.22 cents, which will be the amount of money that Mandla will get after 2 years. So yeah, this is how we do this one. So let's try another one. So our second question says, Mario invests 8,000 into his annuity account that charges 3.7% per year compounded monthly. At this rate, how many years, how many years will it take her, will it take her to reach 12,000 rands into his, sorry for this, I saw that I did a mistake here by this pronouns. So into his investment account. So let's try to jot our data down. What is our A? The accumulated amount, which is the money that he wants to have after so much years, which is 12,000 rands, is the money he wishes to have, and he will be investing 8,000 rands, and the interest rate is 3.7%, which is 0.037. You can test it on the calculator so you can be sure. Correct. So we are now here looking for the number of years, and so now, and it's compounded monthly, so keep that in mind. So now let's try solving for the number of years. So here 12,000 rands and 8,000 rands, 1 plus 0.037 over 12, you still remember monthly, over 12, and n times 12. You can just do 12n. So now here, what's the first step that we need to do? Since remember, we have an exponent here, and the exponent is a variable which we need to solve, so which means we can use the logarithm, if most of you all know it. So under the logarithm, we'll be just using this. So under logarithm, let's say we know that 100 square 10 square equals to 100. So under log, this is the answer and this is the base, this is the exponent. So we just do the base, and the answer here will give us the exponent, that this here it's equals to a 2. So which means we must make sure that we remove this, we divide by it on both sides, and our answer will be 3/2. Then add everything that is inside the brackets. It will give us 1 plus it would be 1,00300, to the power 12n. So so now we can do it in a log format. So under log, we know that this exponent here, it will be equals to log the base of this, which is the base 1,003083333. I know there are a lot of threes and they are recurring, and I just chose to use this one. It's because of I'm going to punch everything in the calculator just as it is. So it's not a train smash, but it doesn't matter. 3/2. So let's go to log 3/2. It will give us 12n equals to 131. And most of you may be questioning that, hey, 121, did I make the correct answer or I made the wrong thing? It's the right thing. You will see how we will get to the final answer. So since now here we are looking for the number of yes, so the reason why this here it's 131,7 what, it's because of it's the number of years multiplied by 12. So that's why it's a huge number. So since we are looking for n, we'll just divide both sides by 12, divide this by 12, and it will give us the final number of years, which is 10,975. And since it's years, we must just do it in a whole number. It will be total of 11 years. You see, so it's basically this 11 years multiplied by 12, which gave us this. So yeah, that's how we tackle it. So now let's go to the last one. So the last one says Michelle wishes to have 1.5 million, or you can say 1,500,000 rands. Yeah, huge amounts of money, a lump sum, ne? A lump sum. So for investment, she invests in a mutual account, paying interest of 9.8% each year, compounded. Sorry for that. Spelling. Compounded semi-annually for 21 years. How much should he deposit into the account? So good. Now here we'll be looking for the principal value, the principal amount. So now this would be the amount that we wish to have, that Michelle wishes to have in the future, which is the accumulated amount. And this is the principal amount we are looking for. We can just write P. The interest, it's 9.8, and 21 years. And it's compounded semi-annually. Keep that in mind. So it will be now let's try to write it down, the formula n times t. So now, oh yeah, I should have left some. Okay, let me just do it like this. It's 1.5, which is the accumulated amount. We are looking for this p here. So now p plus 0,098 over 2. Good. Remember, it's the semi-annually. 21 times 2. So now here we must just do everything here inside the calculator and divide by it, another 1.5 million. So it's 1 plus 0,098 over 12 times 21 times 2. So it will give us P equals to 1,402,0715. Then we divide it by it here. It will give us 1,407,20715. divide by it also here, since we are solving for p. Then therefore the p will be divided by p. No, I did something wrong here. It's 1.5 million divided by 1,4072. Oh yeah, I did a mistake here. I divided by 12. Sorry for that. So now we'll just take this answer and divide it by the 1.5 million. Divide by this. It will give us 201,150 rands, 33 cents. So this is the amount of money that she must invest in order to get 1.5 million rands for pension. So I really had a great time with you today, my fellow scientists, and yeah, hope you enjoyed the lesson too, and enjoy the rest of your week, and goodbye. Cheers.